So this one was a weekly pop quiz. The last week I shared this one, which was related to the moles, the structure question. Oxygen is vital in treatment of the respiratory diseases. Oxygen is traditionally produced by the fraction distillation of air. Suggest one difference between the fraction distillation of air and the crude oil. So what is actually a crude oil? The crude oil is liquid at room temperature. But what about the oxygen or air? Air is the gas. So how the two are different from each other? Because when fraction distillation is done for the crude oil, if you want to do a fraction distillation of a crude oil, we heat it. Where for air, it's a gas. So what we do, we cool down. So that's the main difference. We cool down the air, so it turned into a liquid, and then it changes its state to gas during the fraction distillation. But for a crude oil, we supply heat energy and different fraction condenses at different temperature as it cool down. Yeah, so crude oil is actually heated for the fraction distillation because the crude oil is liquid. So what we do, it's a mixture of the liquid. So first we heat this and allow it to cool at different temperatures. We get different fractions. But in case of air, which is the mixture of the gases, so we cool down the air and turn into a liquid air first, and then that liquid air is allowed to turn back into the gaseous depending on their boiling points. The next question, hospital patients sometimes need to breathe air with a higher than the normal concentration of oxygen. The oxygen concentration can be increased to 90% by passing a dry air through a tube filled with a zeolite, which absorbed most of the nitrogen. A dry air contains 21% of oxygen by volume. The average human breath has a volume of 500 cm3. Calculate the volume of air in dm3 that would have passed over a zeolite to obtain 500 cm3 of a gas which contain 90% of oxygen by volume. So we need the 90% of oxygen in the air. If we have 500 cm3 of a gas, so if we need 90% of oxygen, what volume of oxygen is there? Because we have the percentage of oxygen is equals to volume of oxygen divided by volume of the air or a gas into 100. So first we'll find the 90% of 500 because we should know that what volume of oxygen we need. The question is, what is the total volume of air we should pass? So the person will get 90% oxygen from this volume. So you can also use this formula, or there's also another way. First, you will find the volume of oxygen, like how much oxygen we need. So what is the volume of oxygen we need if we want 90%? So it will be, what is the 90% of 500? So 90% of 500 will be 90 divided by 100 into 500. So when you simplify, it will be 450 cm3. So we need 400, a patient need. At the last, we can convert the answer into dm3. So instead of converting from the beginning, you can convert in the beginning, or at the last you will convert. It won't make difference to the final answer. So means we need 450 cm, 450 cm3 of oxygen. And the question is, what is the volume of air should be added here? Like if we want 450 cm3 of oxygen, how much air should pass over this? So we have the formula that the percentage of the oxygen in air is the volume of oxygen divided by the volume of air into 100. What is the percentage of oxygen in air? It's 21%. because the total 90% of this volume 500 should be there, but how much air should pass through? So this air should contain 450 cm cube of oxygen. So 21%, this will be 450 divided by volume of air we don't know into 100. We cross multiply. So 450 into 100 divided by 21. What's the answer? How much air we need?
2,142.
So 2,142 cm cube. But the question is what volume in dm cube? So we divided by 1,000. So it will be 2.14. Like we write the answer in three significant figure. So we wrote 2.14 decimeter cube. So the question was actually how much air should pass over this zeolite, the catalyst, so that we obtain 450 cm cube, which is a 90% of the total air. Is it clear, this one?
Yes.
The next is nitrogen molecule binds to zeolite with using their outer electrons. Draw a dot and cross diagram for a bonding of nitrogen molecule. So nitrogen belongs to group 5. Group 5 share 3 electron. So if this share 3, this will also share 3. And unshared will be 2. So dot and cross, one of the atoms should be dot, the other one should be cross. Next is liquid oxygen is transported across the world. The liquid oxygen has a density of 1,140 grams per decimeter cube. Like if you have 1 dm cube, this is the mass. Calculate the volume of a gas in meter cube, which is written in bold, measured at room temperature and pressure, that can be obtained from a bottle containing 13.9 dm cube of a liquid oxygen. And the molar volume at room temperature, because it's about the molar volume, so room temperature and pressure, that is equals to 24. 1 mole occupied 24. If it was not the molar, so the unit conversion is always important. If you need the volume, we can use a formula like PV is equals to nRT. We can use this formula. We'll get the same result. Or if I use a formula that moles equal volume of the gas divided by 24. Why I will get the same result? Because PV is equals to nRT is the main formula, and that converted into N is equals to V over 24 when we have a standard condition like room temperature and pressure. So I can directly use this formula, or I can use PV is equals to nRT as well. As we have the room temperature and pressure, so I prefer to use this direct formula. Now, the density is there and the volume is there. So first we should find the mass. So density is mass divided by volume. So to get the mass will be density times volume. What about the density? It is 1,140 times the volume, which is 13.9. So mass is 15,846 grams. Then we work out the moles. Moles equal mass in gram divided by the molar mass. So what about the molar mass? The molar mass of oxygen, as we are talking about oxygen. So this will be divided by 32. If it was oxygen atom, we'll take 16, but it's a oxygen molecule, so it will be 495.2 moles. Now we need the volume, so moles equal volume divided by 24. So we have moles 495.2, volume we don't know, and divide by molar volume 24. So that will be multiplied there. So if the final answer is multiplied, what's the answer for the volume? in dm cube? So 11,884.5 decimeter. So that's the volume of oxygen. But that is in dm cube. The question is in meter cube. How to convert the dm cube into meter cube? So if you want to convert, because the question is written in bold, we need in meter cube. So how to convert the decimeter cube into meter cube? So what we simply do, the final answer will divide it by 1000. So decimeter cube to meter cube divide by 1000. So this divided by 1000, so it will be 11.8 or 11.9. If I write three significant figures, 11.9 meter cube. Is it clear, this one?
Yes.
Next is the total mass of the bottle is 80 kg when it is full of oxygen. Calculate the mass of an empty bottle using your working to C1 and give your answer in appropriate number of the significant figure. So we already, if you see the previous part, we already worked out the mass was 15,846 gram. This was the mass in gram. So we convert into kilogram. So it will be 15.84 kg. That is the mass of oxygen. Mass of the bottle and oxygen is 80. So simply what we have to do, 80 minus 15.84, that will give us the mass of the bottle, which is 64.15 kg. Explain why container to be have such large mass. What is the advantage or what is a limitation to use a high mass? Yeah, that's right. So it can, because what is the reason for that? When it is having a high mass, it will definitely, because it is containing a gas, so the walls will be much thicker. The gas containers are hollow, like inside it trapped air or oxygen in this example. So outside the walls are there, and these walls, because when it is having a high mass, it means the walls are very thick. And when the walls are thick, it means it can hold or withstand the very high pressure. So the points which will score the marks here, you have to mention like the gas container or a gas bottle, this will be hollow, like inside it will be empty. So outside all the mass is because of the walls. So the mass of the container, the walls of the container will be very thick because of the high mass. And when the walls are thick, it can withstand a very high pressure. So the question is simply why the gas container should have a very high mass. That's the question. The gas containers are hollow from inside, like there's no mass inside. All the mass is outside. So if all the mass is outside, it means the mass is only due to the walls. If the mass is high mass, it means that the walls are very thick. And when the walls are very thick, what is the advantage of the thick walls? The advantage of the thick walls, it can withstand a very high pressure. If I say the mass of a cylinder was very low or small, then it means the walls will be very thin. If the walls are very thin, it cannot withstand a high pressure because the gas molecules are continuously hitting it. So it might explode because of a high pressure. So low mass, smaller, like thinner walls with low pressure, it can handle. High mass, thicker walls, so it can hold a high pressure. Is it clear? The next question, 2 grams of a krypton gas is placed in a sealed 5 dm cube container at 120 degrees centigrade. Calculate the pressure in Pascal and assume it behave an ideal gas. So when it behave an ideal gas, we can use the general gas equation, which is PV is equals to nRT. Where P is the pressure, that is what we need. V is a volume, but SI unit, the volume should be in meter cube here. But that is given in decimeter cube, so we have to convert into meter cube. So decimeter cube to meter cube, what we have to do, we have to divide by 1000. So this will be 0.005. N is a number of the moles. How to work out the number of the moles? We have the mass in gram. So from mass in gram, we can work out the moles equal mass in gram divided by molar mass. Mass in gram is 2. And krypton, it's a monoatomic. So you can work out the mass using a periodic table. The mass of a krypton is 83.8. So 2 divided by 83.8, we got the mole 0.0239. R is the general gas constant, which is having a fixed value of 8.31. T is the temperature, but that should be in Kelvin. So it's 122, 120. You have to add 273. So 120 plus 273, this will become 393 Kelvin. So this will be 393 Kelvin. So you just need the pressure. This will go there in division. We'll get the final pressure, which is about 15,600 Pascal. So for these questions, what is the important thing is a unit conversion. Sometimes you see a question, but you don't convert a unit, the final answer will be wrong. So volume should always be in meter cube, temperature should always be in Kelvin, and you should have the moles, and the pressure should be in Pascal. Sometimes it is in ATM. So 1 ATM is equivalent to 100,000 Pascal or 1 exponent 5 Pascal. So unit conversion is the most important thing for these questions related to the ideal gas. In this question, which is actually related to the empirical formula, 0.02 moles of of element Z react with an excess of a chlorine to form 0.02 moles of a liquid chloride. The liquid chloride has a formula of XClN, where N is an integer, and Z and Cl react vigorously with water at room temperature to give an acidic solution and a white solid. When excess of silver nitrate or AgNO3 is added to solution, 11.4 grams of AgCl form. Suggest the type of a bonding. Suggest the type of the bonding in ZXClN. How we can predict the type of the bonding? As you can see, when it is forming a compound, liquid chloride. So when a compound is liquid at room temperature, what you can predict about the type of the bonding, you can simply say, because if it was a solid at room temperature, then we can say it will be ionic. But in this case, it is covalent. Why it's a covalent? How we predict it? Because it is a liquid. And what kind of covalent? It is a simple covalent or molecular covalent, you can also say. Is it clear? The first point, how we predict the type of the molecule as well as the type of bonding. Why simple? Because if it was a giant or a macromolecular structure, then this compound should be solid at room temperature. So when we predict, what are the characteristics? If the two possibilities are there, it might be ionic or it might be covalent. These are the two bondings. It cannot be metallic because the metallic exists within the metal, and chlorine is not a metal. If it is if it was a ionic, it should be solid at room temperature. If it is a covalent, it might be a liquid or a gas. So first thing which give an idea, it's a covalent because you mentioned it is a liquid. So if it's a liquid, it's a covalent. The type of the bonding. So we identify it as a covalent. And the second thing, what kind of covalent? Because it is a liquid. So what kind of covalent? It should be liquid and a gas. They are simple covalent. If it was a giant covalent, then it should be a solid at room temperature. Is it clear now? The bonding and the structure? If it was a solid, if it was a solid, like in the question, then there should be another information about that. If it was a solid chloride, then there should be another information about the conduction of electricity in a molten or aqueous. That information should be there. Because if it is a solid chloride here, it might have a covalent or a giant structure or a ionic structure. Then there should be another information that about the conduction of electricity in a molten or aqueous. If it was conducting electricity and not conducting in solid, but was conducting in molten or aqueous, it means that it should be ionic solid. If it was not conducting electricity at all, it will be a giant or a macromolecular. The next is the value of N we need. So we can simply use what we can do, we can simply use the ratio of the moles from the information here. When excess of a silver nitrate, AgNO3, is added, 11.4 gram of a silver chloride is formed. So graphite, yes, graphite can be, but it is exception. And graphite is not a chloride. Graphite is all the carbon atoms are there in a hexagonal ring. So it cannot be graphite, because if it was a graphite, as I already mentioned, it's a chloride, like chloride. So it cannot be graphite. Graphite means it contains all the carbon atoms. Now, how to work out this? So we have ZnCl with a N, like any integer is there, and it was reacting with silver nitrate. Okay. And it was what it will form? It will form silver chloride. How many moles are there for this liquid? We know this is 0.02 moles. Now, how many moles of silver chloride are there? Because the mass of a silver chloride is given. So first what we'll do, we'll work out the moles of silver chloride. So how many moles of silver chloride? Moles equal mass in gram divided by molar mass. Mass in gram is how much? Mass in gram is 11.54. Okay. What about the molar mass of a silver chloride, AgCl? So chlorine is 35.5. And what about silver? You have to use a periodic table. What is the mass of the silver? The molar mass of a silver. Use the periodic table. I think it's 109 something. The molar mass of a silver is 107, 107.9. So I can put 107.9. So what is the total here? This will be 11.54 and 107.5 plus 35.5. Sorry, 107.9 plus 35.5. So the total mass will be 143.4. And when we divide, how many moles we got? We got 0.0805 moles. Is it clear till this point? The moles of the silver chloride.
Yes, sir.
So moles equal mass in gram over molar mass. So we got the moles of silver chloride, which is 0.0805. Now, what is the simplest ratio between a silver chloride and this liquid chloride? So what is the simplest ratio between them? How to take a simplest ratio? So this will be 0.02. This will also be 0.02. So this will be 1 and this will be 4. So it means if we have 1 mole of a zinc like this chloride, how many moles of a silver chloride will form? 4. Because the ratio, the simplest ratio between this liquid and silver chloride is 1:4. So if it is forming 4 moles of zinc chloride, silver chloride, how many chlorine should be present here? So how many chlorine should be present? There should be 4 chlorine. Because all of those 4 chlorine will react with the silver and to form 4 moles of silver chloride. So what is a integer value for this? And the value of the n, because the formula will be not Zn. By mistake I wrote Zn. It should be Z. So this is ZCl and we have AgNO3. So when we took a ratio between them, the ratio is 1:4. It means 1 mole of ZCl will form 4 moles of AgCl. So to form 4 moles of
Yes.
AgCl, how many chlorine should be there?
Yes.
So to form 4 moles, so to form the 4 moles here, how many chlorine should be there? So there should be 4 chlorine attached. That's why the integer value of the N or the chlorine is equals to 4 here. Is it clear, this one?